Hi, and welcome to Academic Compliance Academy of Law and Economics. So in this video, I'm going to talk about how do we solve a strategic form game when there is presence of weak dominance. So let's look into what this weak dominance really means, because when we try to solve games in game theory, where there's presence of dominant strategies, we typically divide them into two parties. It can be strict dominant strategy or a weak dominant strategy. A strict dominant strategy is when there's a strategy where the payoffs always are higher than the payoffs of any other strategy, no matter what the other player plays. When we talk about weak dominant solutions, it is kind of different. So let's look into it. So a weak dominant solution is a solution where we observe the strategies of each player in a game and deduce the outcome of the game by looking at each party's weakly dominated strategy. So what is this weak dominance thing? Well, weak dominance equals that no other strategy gives a higher payoff or output, no matter which strategy the other player plays. However, the payoff can be the same in some strategies. What does that mean? Well, it means that if we look at strict dominant strategies, no matter what the other party plays, you always, if you have a strict dominant strategy, you always gain more payoff. You have a higher payoff no matter what. When we talk about weak dominance, it can be higher or the same as another strategy. It might become more clear when we go into the solution model. So let's look at the actual solution. So I put up here a 2 by 2 matrix in a strategic form. It is asymmetric, and we have two parties, each with two different strategies, both of them named A and B. So let's start with player one. Player one has two strategies, A and B. The payoff depends, of course, of what player 2 chooses to play, which strategy he or she plays. If player 1 chooses strategy A, he can either get 3 or 0. So you see that player 1's payoff is the first number before the division of a comma. If he chooses strategy B, he would get 2 or 2. So when we look at these numbers and these payoffs, can we say that one of these strategies are better than the other in most cases and might equal, or whenever it's not better, have a higher payoff? It is at least equal to the other solution. Well, let's look at the first. If player 2 plays A, then player 1 would, by strategy A, get 3, by B, get 2. So here, A is better than B because it gets a higher payoff. If player 2 plays strategy B, then player 1, doing the rows, by playing A would get 0, by playing B would get 2. So here, B is better than A. So either A is best or B is best. So there's no overlapping strategy that is better than the other, better or the same as the other, which means that there is no weak dominant strategy for player 1. But this will be interesting later when we have to come to a solution, because now we have a problem because one of our players doesn't have a dominant solution. But let's look at the other one because he might have. Player 2, two strategies, A and B. If player 2 chooses strategy A, then he or she would get 1 if player 1 chooses A and 2 if he chooses B. So what is important here is when we look at the payoffs of player 2, that is the second number, so after the division comma. So if he chooses A, he could get 1 or 2. If he chooses strategy B, he would get 0 if player 1 chooses A and 2 if player 1 chooses B. 0, 2. So now we have to compare the two strategies. So if player 1 chooses A, player 2 can by strategy A get 1, by B get 0. Then he wants the 1 from strategy A. So A is better than B, it has a higher payoff. If player 1 chooses strategy B, then player 2 would get 2 no matter which strategy he chooses. And this is where it becomes a weakly dominating strategy to play strategy A, because it is only better in one case and in the other it is equal. So here we can see the difference between, if it was supposed to be a strict dominant strategy, then player 2 would have to get more than 2 if player 1 chooses B, because it had to be better than the alternative, better than the payoffs he would get by choosing strategy B. So what we can say here is that player 2 does have a weakly dominated strategy, and that is strategy A. But wait a minute, we didn't find anything for player 1. Well, we just have to think a little bit. We know that when we have this strategic form game, we know there is perfect information. Both players can see all these numbers. And given that assumption, given that A has a weakly dominating strategy, or is a weakly dominating strategy for player 2, and that player 1 knows this because he can see the numbers, well, due to this perfect information, he can choose which strategy optimizes his payoff under the assumption, of course, that he can see the numbers. And because of that, well, the choice is quite simple. We know the player 2 have chosen and will choose A. So player 1 will have to see, okay, what are my possibilities? If I choose strategy A, I will get 3 as my payoff. If I choose B, I would get 2. Given that, we know that he would play strategy A. So the solution to this game is AA, strategy AA, giving the payoffs 3 to player 1 and 1 to player 2. Even though there's only one party here who actually has a dominating strategy. Very important, weakly dominating strategy, not a strict dominating strategy. So this is just an example. You can have a lot of different games, some of them even where both parties have weakly dominating strategies, some of them where one has strict dominating strategy, the other has weak. Try to mix it all up and try to put in numbers. Do yourself that gift that the more you exercise these type of games, the better you become. This was just a video on how to solve games in a strategic form with perfect information when we have presence of weak dominance. So stay tuned, subscribe to this channel, and let's talk much more about law and economics.